Can you please let me know whether are you able to see my screen or not?
Yes, sir, visible.
Visible, sir.
Okay. Okay, thank you. Yeah. So as we are discussing the design period in the last class, so just immediate after the design period, the next aspect which is very very important to consider is the population prediction, or within the design period, which I mentioned yesterday also, that for this next couple of decades or 3 decades, the population number of population in a particular society will not be the same. Like if you consider today in Jamshedpur city and the population which it will get in next 3 decades, the difference will be huge in number. And being a environmental engineer and being a civil engineer, when you have been given the responsibility to design water supply scheme, so you have to understand how this population growth would become after 3 decades or after 30 years, or let's say after 20 years. And accordingly, you would be able to calculate the per capita demand. So, when the design period is fixed, the next step is to determine the population forecasting. Fine. Why population forecasting? Because we need to determine the population of a particular society for the entire design period of the water supply schemes, and that may have impact of several factors like births, death, migration, annexation, and several natural calamities also can happen, and which may cause a very drastic change in the overall population. So the future development of the town, mostly depends upon the trade and business aspects and how it is going to expand in that perspective. Development of several industries, and in the surrounding countries, the discoveries of new mines, construction of highways, railways, freight corridors, and at the same time, if that is nearby to the sea or big river, then what is the aspect of construction of port? If it is a city which is basically significant because of its port, then how much would be the expansion in the next 30-40 years? That part also has to be considered. Now for this prediction, it is better to study the development of the similar town. If you see in India and as well as in the world, we have some sister cities and towns. Now if someone has done some population prediction of a sister cities, where the age of the cities are same, nature of growth of population are also same, in those cases, it's better to predict based on the similar towns or cities which have developed under the same circumstances, because the development of the predicted town will be more or less on the same lines. Fine. Now if we say, like, there are several factors which can change the population, so I have already mentioned. So we have increase due to births, decrease due to deaths, increase or decrease due to migration, and increase due to annexation. So these are the most important factors, and there might be several other factors, as I mentioned, natural calamities, some bigger accidents. So those are not usually considered, but these are the factors needs to be taken into account while predicting the population or while forecasting the population. So the present and the past population record of the city can be obtained from the census population records. In our country, we have census data for each decade, and after collecting those data, population figures and the population at the end of the design period can be predicted using different methods, which we are going to discuss now. And depending upon the growth pattern of those cities, we can actually predict, and that prediction is quite realistic. I mean, it has been observed from the previous practices that this prediction which we will do is quite realistic. And for different nature of cities, different nature of growth rate, there are different methodology which is most suited, and we'll be discussing subsequently that in which kind of city and in which kind of nature of population growth, which particular methodology would be most suited or would be most apt. So that part we will also discuss. Now, with this, there are few more points here. I would tell you that so this steps I have already mentioned, and now we'll see the methods of forecasting. So we have several methods. The first one which we'll start with is arithmetical increase method. Number two, geometrical increase method. Then comes incremental increase method, and followed by simple graph method, decreased rate of growth method, comparative graph method, and the master plan method. So these are the available methodology which one can go through before predicting the population of a particular city or town. Now, before going into further details of several methodology, let me talk about a bit on the growth curve. And this growth curve is very, very important to understand, because this growth curve is nothing but the nature of growth which may happen in a particular city or locality in country like India. So what would happen is, when whatever factors which we discussed, when they are not influencing that much in extraordinary level, then the population would probably follow the growth curve characteristics of living things within limited space and within limited economic opportunity. And this curve is known as S-shaped curve, or this is also known as logistic curve. So we have a straightforward method of prediction also with this curve. However, before going into that, let us understand what this growth curve is. So when all the factors are not influencing significantly, we can still try to understand that how this growth can happen as far as population is concerned. So the curve represents early growth, at the portion AB at an increasing rate. So in the initial part, as I mentioned over here, you can understand that the geometric or log growth is happening. So with respect to time, the population growth is actually proportional to the number of population. Then comes another one part, which is the last part, that is the DE in the right hand side figure. So that part is known as the decreasing rate. So you will see in this part the rate of growth is in decreasing order, and as per the first order curve. So in this case, ddt of P is proportional to PS minus P, where PS is the saturated population. Fine. So you should be able to understand from this figure how this, with respect to time, how the population can change in a particular city, and you should have an idea that what would be the saturation population also, or saturation value. Now, if you consider the BD portion, which is still undiscussed, and I would like to discuss about it now. So this part is basically the transition from the higher growth rate to the lower growth rate. So this is the transition zone where arithmetic increase happen. That means dP by dt is constant. Fine. So they are simply in arithmetic increase. So we have three different distinct segment in the growth curve. So that is why we say what the future holds for a given population depends upon as to where the point lies on the growth curve at the given time. So this is very, very important to understand and keep your mind before you start population forecasting. So with this, we'll be discussing the fast immediate method. So that is arithmetic increase method. And if you see here, basically arithmetic increase method is this method is mostly suitable for large and old city with considerable development. So the city which is large and then the city which is pretty old, so the agglomeration has got started for a significantly higher period of time, maybe for 3, 4, 5 or 7 decades. So those cities population can be predicted based on the arithmetic increase method. So on the other hand, if you use this for a small and average or comparatively new cities, it will give you lower population estimation than the actual value, and which is very, very undesired for our conditions, because we cannot afford predicting lower population than the original which we are going to get. Instead, we can still afford being in the conservative side, that is predicting something which is slightly more than the realistic population which it would get in the next couple of decades. So what is done in this method? So in this method, the average increase in population per decade is calculated from the past census data. So you need subsequent past census data for few decades, and then only you would be able to work out the population prediction based on the arithmetic increase method. Now the increase is added to the present population to find out the population in the next decade, and thus it is assumed that the population is increasing at constant rate. So you should be able to understand what we discussed in the B2D segment, and the same prediction is being applied over here, that dp by dt is equals to constant. That means rate of change of population with respect to time is constant, and that is why it seems logical to take that increase in population every year and just simply we can predict by multiplying the number of decades. And therefore if you see here, the population after nth decade would be Pn equals to P plus NC1, where Pn is the population after nth decades and P is the population, and C1 is basically rate of change of population with respect to time. So if C1 is actually the increase, what see this increase is added. So basically when we compute this increase, so this is that increase which we will actually work out, increase per decade. Fine. So with this we will be able to, so that increment is, that average increment is C1 in this case. Fine. So you should be able to remember this. So we have one example problem. All of you should do that in your paper or copybook, and you should let me know what problem you are facing in solving this problem. So the problem says that predict the population for 2021, 2031 and 2041 from the following population data. So we have data since 1961, so we should be able to get the average increment per decade. Once we get average increment per decade, we should be able to calculate the or predict the population for 2021, 2031, and 2041. So now what I want is, I want to get your answer in the so all of you should tell me the answer which you are getting for this particular problem. So first tell me what is the value of average increment. So what you should do is, how you should solve this problem. I'll tell you in one case. So what you can do is you can make a column like this. Fine. So you will write a year over here. You will write the population over here, and you will write the increment over here. Fine. So if we make column like this, and if we divide this in row, I am not going to write everything, but I'll tell you how this problem should be calculated for your convenience. So you will have here, like in this case, we have 61, 71, 80, 81, and then 91. So T1, and then we have 1, and then we have 11. So population also you will get over here. You should write the population, and then in the first case you will not get any value for the increment. So this particular cell remain blank. Fine, because in this particular cell we don't have anything to fill up. Here we will get the value. So that is basically this minus this. So this will come here, likewise here, likewise here, likewise here, likewise here. So now you will get a value that is, and then you need to take the average. So average increment you would get, you have 5 average 5 increment value over here. So you will get the average increment value from here. So that is our C1. So you will be able to get the C1. Once you get the C1, so you simply put that formula Pn equals to P0 plus n into C1. So for 2021, basically your n equals to 1. For 2031, your n equals to 2. For 41, your n equals to 3. So this is what actually the entire problem. Now I would like to get the answer from most of you. Hope you have written the question. Can anyone respond? Let me go back the previous. Fine. Ankit Raj has given. So just you tell me the average increment, that value. So that value is important for me. And I want to see, like, all of your 80 students are present in today's class. I want to get the respond over here from each and every student. You have to type in the chat box your answer. Okay, that is correct, Akshay Kumar. That is correct. What about others? All the CRs, you should take the initiative to start the interaction, and you should talk to me regarding this, and you should actually share the and the problems, how you are doing and everything. So, and anyone else, if you have any issues while solving this problem, you can let me know. Okay, so the first value is correct, Ankit, so that means the others will also be correct. Aman, this is correct. Okay, very good. See, if you can calculate the average increment, the rest of the problem is easy, no problem. Remember one thing, these problems are very simple, and you will get such problems in your semester as well as in some of the competitive exam. But then, since this is simple problem and this is a sure shot marks you can obtain, so that is why you have to be very very careful, and you have to ensure that you don't do any calculation mistakes while solving this problem. Right? All prediction problems are pretty much simple and easier. This one problem we are doing over here, and I guess all of you will be pretty much confident while you see such kind of problem in the semester exam. If any one of you are facing any issues regarding understanding and solving the problem, please let me know. This is the best time to discuss. Since I have discussed the theory just now, it will be easier for you people to understand this problem. So can I proceed for the next part, or you will take some couple of more minutes?
Excuse me, sir.
Yes, please.
Sir, won't we omit the decimal part since population should be whole number?
Yes, true. That's absolutely true. You should be not writing in terms of point. Point is what you are getting, so you just say one more. So if it is 0.4, so you say 83.4 means 84. That's it. Or that is the conservative way. Or even if you write 63, since it is less than 5.5, that is also logically correct. So anything is fine. If you take one more, logically, we cannot do the percentage or decimals of number of heads. So that is why even if we get to 0.25, even if we get 0.15, we can take one extra. Or if you go by the usual rules, you can go by that also. There is no problem as such, because this one number would not be very very significant. It's a trivial one. Fine. So this is a good point raised by you. All of you should keep that in your mind. Once you finally present the population of P2021, P2031, P2041, there should not be any decimal in the representation of the final population, because it cannot be in any decimal. So you have to round it off, maybe based on the classical rounding of theory, or you can do it by logic that next one full you should consider. So is that okay? Can we go to the next part? Most of you could do this problem.
Yes, sir. Yes, sir.
Okay, fine. So Let me again share my PPT. Yeah, so this is the solved problem. But I wanted to show you the table, how it is made and how we should be doing for the next problem. So next comes geometrical progression method. So this is also very important one. And geometrical increase method, the main thing is, what is done is, in this method the per decade percentage increase or percentage growth rate is assumed to be constant. So there is a difference in the basic assumptions with respect to arithmetic increase method. So in geometric increase method, what we say is the per decade percentage increase or percentage growth rate is assumed to be constant. Fine. And the increase is compounded over the existing population every decade, which is not done in case of arithmetic increase method. We don't compound each decade population. So once we get the, in case of arithmetic increase method, just I am repeating again for your better understanding, what we do is, let's say we obtain the population data, census data up to 2011. So once we calculate 2021, or once we predict 2021 or 2031, so 2011 is our 2011 population is our base. So every time we are taking that. However, in this case, it will be compounded, so it will be changed. Your P0 will be changed every time. Fine. So that is actually here. If you see, so the second point is very important. Increase is compounded over the existing population every decade, also known as uniform increase method. That is why it is known as uniform increase method. Since this method gives higher values and hence should be applied for new industrial town when it is at the beginning of development for only few decades. So for the young and as well as developing town or cities where a lot of industrial activities are going on, we can consider geometric increase or method or geometrical progression method. So this is what is geometric increase method. Now, how the population can be predicted? So the population at the end of nth decade, En, can be estimated as 1 plus r by 100 to the power n. Now this r is geometric mean, and we are going to obtain that. P is the present population and n is the number of decade. Now this P would get altered for every decade population prediction. It will not be same. Unlike in arithmetic increase method, you see this P here, if you see this P is constant, right, in each three cases, which will not be there in case of geometrical progression method. So the assumed growth rate R can be computed in several ways from the past known population data, and one method to compute is basically R equals to P2 by P1 to the power 1 by T minus 1. So where P1 is the initial known population and P2 is the final population, and T is the number of decades between P1 and P2. So that is one way we can basically calculate. Fine. So square root of T under P2 by P1 minus 1. So that is one. Another one is, the other method to determine R is to compute the average of the percentage growth rates of the several known decades of the past. So the growth rates is basically increase in population by the original population into 100. So these values are computed for each known decade and their average can be taken. So in that case, the geometric average would becomes, square root t, and then whatever r1 into r2 into r3, all those r would get multiplied and then under square root t. So this would give you geometric average. Fine. So just try to remember, again I am repeating, the growth rate is basically increase in population by original population into 100. And once we get for each decade, past decade, like R1, R2, R3 to RT, we should be able to calculate the arithmetic average. Geometric average. In some cases, we can, the average may be taken as arithmetic average, and in that case, that's a simple, average what we take. So arithmetic average would give you, more prediction compared to geometric one, and sometimes we recommend that. Fine. So though you may find that geometric average is giving realistic value, but to be in the safer side, what is done is arithmetic average has been seen giving the higher value of forecasted population. So that is why, engineers prefer to take that arithmetic value. However, if you see that manuals and codal provisions in Government of India manual, you will see that in most of the cases geometric mean is recommended. So if it is not mentioned in the exam, you take geometric mean. If it is mentioned that you can get that mean by arithmetic average, so after obtaining R1, R2, R3, you can go by the arithmetic average. But if it is not told, then you should go by geometric mean only. Is that clear? So now if we try to solve the problem 1, and if we now try to do it based on the geometrical progression method, so how can we do that? So can just start doing this. What did we say? So similarly, the table which we actually created in the previous problem, same table you need to create again. So you have to write in the left side column years, and then immediately next you will write about the population in different decades, and next you will write the increment. So in increment column, the first cell would be vacant because you will not get, since this is the first population which you have obtained. So in the second onwards you will obtain the increment, and corresponding to increment you will get the geometrical increase rate of growth, which should be calculated as increase in population by number of population into 100. So you will get a value, and accordingly you will get a percentage value. So you write it, you just obtain it, and then let me know. So I'll not show it now. First you people should do it. So if I tell you, we'll have one more here. So this is year, this is population, this is just increase in the population, and this is the geometrical increase rate of growth. So we have here, 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 here. So we'll get one increase, and we'll get here also one. So if we say this is I1, so we'll write here I1 by P1. So this is our P1. So I1 by P1 into 100. So likewise for this, if you get I2 over here, and this is your P2, so you will get I2 by P2 into 100 over here. So likewise, you should be able to calculate the geometrical increase rate of growth. Okay, this is fine. So geometrical average becomes 23.5. Ankit Raj, this is correct. So all of you should do that. Rahul Kumar, that is also fine. You can write in terms of, if you write 18.3, you have to write percentage, or you can directly convert in decimal and you can write 0.18. For Rahul Kumar, I'm telling that. Usually we'll express it in terms of decimal. So you write 0.18, 0.18, 0.4, 0.22 or 23, and then comes 0.24. And you take the geometric mean average of that. So in this case, it will become, your value would become, R would become all these 0.18 into 0.18 into 0.40 into 0.23 into 0.24 to the power 1 by 5. Fine. What about others? I can only see answer from 3 people. Yes, 93.778. Rahul Kumar, you write 0.23. Don't write 23.778. It's or you write 23.778 percentage. Fine. Otherwise, this will be an erroneous representation. Yeah, that is correct. What about others? So once you get the value of R, things become very, very simple. You should be able to calculate for different decades. One thing you should remember over here, now I guess some of you have already got the value. Now let me discuss this part. This is an area where you should do mistake. You see, as you have already compounded the increase, so this time when you calculate the final P, the last P which you have obtained, so from the census data, this is your P for every time. If you again compound it here, then it will be a twice compound, which is not desired. So as you have already compounded the increment of rate of growth, so every time your P would be this value. So P0, you can consider this is as P0, since you are compounding here. Your increment is getting compounded over here. Okay? So each time your P0 will be the last P. In this case, 258, 5862. You need to understand the logic.
Sir, how R is calculated? Please repeat.
R is calculated. So what we are doing here, up till here, right? Increment, how we are getting the increment. So you see here, what we have done is basically this by this. Same thing here I have written. If this is your P1, this is your P2, and increment you will get from second row only. First row it will be blanked. So if once you get I1, so that is the first increment, and now you want to calculate the G1, or G, will write it in R, so to reduce your confusion. So this is our R, right? So R means we will get the R1. So R1 is basically I1 by P1 into 100 in percentage, or if you directly want to get it, you just simply I1 by P1. If you do, you will get in decimal, and that is what has been done over here. So this is our I1, this is our P1. So I1 by P1. Likewise, in this case, I2 by P2. Here in this case, I3 by P3, I4 by P4, and I5 by P5. Fine. So P6 is not getting here, but since we are compounding here the increase, geometrical increase rate of growth, so that is why every time we are taking this as P0. Understood? I don't know who asked me this question. Have you understood?
Yes.
Okay. Okay, fine. So what about others? All of you could do this problem, I guess. No problem as such. If any one of you are having any issues regarding understanding this problem, please let me know. Okay, in that case, I can assume that all of you have understood by now. So we have discussed two mostly used forecasting method, that is arithmetic increase method and geometrical increase method, and we'll discuss further in the next class. So geometrical increase method is also known as geometrical progression method. So with this I will finish today's class.